I'm passing over to Frank. Frank is going to talk about something that is really gaining momentum in other parts of the world and introducing it to here, I guess. Frank, over to you.
I guess we're left to wonder which is the red pill and which is the blue pill. So my subject today has to do with fiber to the room, which is a up-and-coming technology that's seeing a lot of deployment just now. So a little bit of introduction. So ETSI has a project called the Fixed 5G Industry Standardization Group. And it's basically looking at trying to homogenize all of the standardization of fixed networks, a lot like has been done with wireless in the 3G, 4G, 5G wireless that we've had and gone through orderly migrations of roughly every 10 years. We thought it would be a good idea maybe to try to do the same trick with fixed networks. And so this project is really, it's end-to-end. It's trying to look at all different kinds of aspects of networking. And there's a lot of, they start usually with a triangle diagram of different dimensions they're going to explore, and then that evolves into a hexagon. So there's always more things to sort of think about in terms of making network better. So like enhanced fixed broadband is basically, that's mostly speed, just trying to get the capacity of the system greater. GRE, great guaranteed reliable experience, that's more of these things like latency and reliability, things that will work and just work and not fail on you at the critical moment, right? And then there's this third dimension, which is the full fiber connection. And that's kind of where fiber to the room starts to come in. So once optical access and PON has become successful, we've gotten fiber out to the home. Now we're looking at maybe taking it into the home so that we can actually get the fiber as close as possible to the final end user devices, and that should produce benefits, and indeed we find that it does. So some of this work, ETSI has made use case studies about fiber to the room. ITUT has recently standardized architectures and actual, the nuts and bolts, the TC layer and the physical layer for how to do fiber to the room in the past year or two. And also CCSA, which is the Chinese Standards Association, has various standards approved in this area as well. So just a few numbers are sort of showing how it's being rolled out in the world. So one interesting number is, like how many different users have a gigabit, top line service to their home. Apparently 172 million users, probably more than that now. That's about a year old now, that number. Fiber to the room residential users, that's around 17 million households now. So that's quite a sizable number. It's really grown rapidly over the past couple of years. And then fiber to the room more for commercial use for businesses. There's 75 or so state and regional operators that are involved in services they're leveraging this kind of technology to essentially produce telecom type LAN services, going in serving a business so that they don't have to have their own IT department and that sort of thing. So that's sort of showing that fiber to the room is a building scenario. So the focus today is really introducing intelligence for this, so that when we're doing fiber to the room, how can we do that job better? And so, right now we're in the intelligence era. The first era was like the E era. Everything had to be like e-commerce. Then it was I. Well, now we're AI, I guess. So everything has to be intelligent, of course. But there are certain areas that really need, and can benefit from improvements. So the first one, of course, the first thing that you hit is fiber deployment. So how can we make that initial deployment of the technology into people's homes and businesses work better, work smoother, require fewer, skilled individuals to implement it, because we know that there's a manpower shortage generically. Then look about improving the architecture, improving connection management and making that more intelligent, doing intelligent management of that's more like service management kind of aspects, and then even making more intelligent services themselves, so sort of on top of the basic network. So let me talk about each one of those in turn. So the first one is intelligent fiber planning. So when you go to a home and you want to do a fiber to the room network, you first have to have some kind of idea of what the home is, what its internal structure is. And there are fairly automatic ways of trying to obtain a floor plan for individuals' homes. A lot of this has to do with kind of software applications that you run on smartphones. So just by waving around your phone with a little bit of guidance from the system, you can actually develop a map of the house. So that's useful. And then you can plan out the network, do simulations to kind of see what the coverage of the Wi-Fi is, because essentially, well, maybe to back up a little bit, fiber to the room gets the fiber to each room, but then we anticipate there's going to be Wi-Fi or some kind of wireless technology that actually connects to the final computer or cell phone or whatever the user is using, television set. So it is all about Wi-Fi and trying to make Wi-Fi work better. So if you put the access points in the right place, knowing the layout of the home, you're going to do a better job. So that's a lot of improvement there. And then also about installation, there's work there about trying to plan the network, try to figure out how you're going to run the fibers. And a really big improvement that has been implemented has been this kind of transparent fiber. So it's a very lightweight fiber cable, so it's like 900 micron buffer type of fiber. So it looks like fishing line, basically, right? And you can, it has adhesive, so you can just bond it along the corner of the wall between either the ceiling and the wall, or the wall and the moldings on the floor. And then that way you can get around the room and you can make your fiber connectivity. So that's really, that's essential. I mean, in some places you get fortunate and there's ducts. Most places there's not. So this kind of very lightweight fiber cable is enabling the physical layer for these things. And then once you've built it, you now have to go through and actually see that it doesn't work. So you have to have connectivity acceptance. Do you at least just get connection to all of the devices that you're trying to deal with. You want to look at experience acceptance. How much is the speed and you can have the user. A lot of this stuff is user install kind of things to at least, maybe not at the beginning, but during troubleshooting. You can have using his cell phone. He can walk around his house and see if there are any dead spots or whatever. Checking sure that the roaming capability works, so that there's acceptance tests there that you can do to check. And then user visibility. This is an important part that you have to make sure to actually show the customer what you've given them, because the network is invisible. You can't tell that the coverage is good everywhere in this room. But if there's something on his cell phone that you've done this test and it actually works, and sort of there's the test data to prove it, right? That's an important thing and delivers value to a lot of customers. So then the next thing is sort of network architecture. So a lot of this is trying to build a more deterministic experience. So we're trying to manage getting better coverage, handling roaming so that you can move around the house and not have big disruptions in your connectivity, and anti-interference. That's really the big one. Because, I mean, it's always easy to turn up the power, but everyone turns up the power, and then you just don't get any good capability whatsoever. So it's really coordination of all of the radios in the environment is important. And a lot of that has to do with having the system automatically recognize what the environment is, doing measurements, so looking at what the interference is, and then trying to figure out ways to work around it. And of course, part of that has, the answer to that has to do with how you can coordinate with the other networks that are in the building, say. A lot of these, the sort of the advantage of having a network operator derived Wi-Fi service is that you might, be actually in control of many of the Wi-Fi access points, not just in this one apartment, but the neighboring apartments too. So you can coordinate over a much larger scope, and you can do better performance that way. But in a lot of these things, there's a lot of data that needs to be pulled in, analyzed, try to figure out a solution. You can't be doing that manually or even with the customer's help. You need to have something more like AI to be able to do the inference, to figure out what's going on, and then also come up with like templates to how to configure the system, and then also watching the characteristic of the traffic and where people are in the building and how they move around. And you can do some kind of predictive roaming kind of policies so that you can try to better partition the network and get the best performance for everyone involved, right? So, and then of course, then there's also the possibilities for slicing. So you can try to reserve some frequencies or some time slots for deterministic latency, so you can do more advanced services like this. The gaming console, those want to have the lowest latency so they can shoot the gun first, of course. And then another big connection is with millimeter wave. So millimeter wave, the problem with wireless is always we don't have enough spectrum. So if you want more spectrum, easy, just go higher frequency. And eventually you get to the millimeter waves, and that's great. One problem, well, they don't go through walls very easily. So, but that's fine. Fiber to the room will take care of that, because it'll get through the wall, and now you're in each room with an access point. Second problem with millimeter waves is, well, they're small. And so their antennas have to be small too. And so to get any kind of decent power and antenna coverage, you have to have multiple element antennas. And now you have to have the way to intelligently combine all of the signals from those different little tiny antenna elements into a usable signal. And so there's so much more control that you need to exercise over those kind of access points. And that's something that, pretty basic kind of intelligence, just sort of how to form beams, how to lock onto a particular user and then track him as he moves around the room. So that's the control side. But then in the reverse, now you actually have, essentially like a phased array radar inside of every room, tracking everything that's going on. You actually can tell a lot. Even it's a communication system. It's not trying to spy on you, don't worry. But it's, you can actually tell, where people are. Basically just the mass of your body is like a RF absorber, so you can detect it. So it's actually interesting. There are a lot of like sort of value-added features you can increase to do that. So there's a lot of different intelligences that need to come in that regard. And then intelligent management. So this is more, like I said, the sort of the business management side of using all of this smart networking capability to try to figure out where your customers are, what are their real problems, and where can you go and try to solve their issues. And in that way, you can target your marketing even to be driven that you can tell that this particular building is having a really bad day with Wi-Fi. Maybe that's a good time to go in and try to market those people with a better service, right? That's something that can be done. So, and all of the other, self-service features, like the security, parental controls, that kind of stuff. It's really, there is a latent demand for all of those things. And I think this is where this could really help. And then sort of on top of all of that, we have to try to move beyond just being a dumb pipe, right? So I think most of the talks I've seen today, we're moving past the age of speed. So it's no longer just speed. Now it's more latency or experience. But I think we have to go even further, and we have to move beyond being just a telco. We have to, it's not good if you provide the basic infrastructure and then the over-the-tops, take all the profitable services. You have to start taking those services back. And fiber to the room networks allow you to, gives you a lot more, entry into the home. And there are all these different kinds of services, smart entertainment, care for the elderly as the population ages, that's going to be an issue. Storage, everyone has so many videos and pictures now. I don't know what I'm going to do when I have to change my phone next. So it's really, I know, and you're going to lose it all someday. So it's terrible. But, and all of that. And that can really be, integrated into this smart home network. And a lot of storage can be put into the ONUs pretty easily, as well as computing. Actually, the most recent versions of the ONU devices that my company is making actually have a neural processor built into it. It turns out that there was empty silicon that they couldn't figure any use for. Well, let's put a small artificial intelligence engine there. Why not? It doesn't cost anything. And indeed, that's going to be a latent resource that we will then be able to mine, maybe not today, but tomorrow. That compute processing is there, and it's being hosted by the subscriber. So you don't have to build a new data center. It's already there. And it's, of course, it's located there. You can use it to crunch all the data that you're gathering inside the home to help reduce the amount of telemetry that you need to send back to the network. So just the outlook of this. So really, we're moving from a guaranteed experience, from best effort to guaranteed, all the different improvement metrics that we're looking to try to increase the actual true capacity of the Wi-Fi, reduce its latency. A lot of that has to do with contention management and interference avoidance, as well as increasing the number of devices. Those, it's always you're always getting more and more devices. So, and usually it's not so much bandwidth each device, but there's just a mass of connections that you need to manage. More intelligence, trying to move towards collective intelligence so that we have individual intelligent appliances, but if they could all work together in some way, you can get a synergy of the capability there. And then the last but not least is sort of this ecosystem that we have to build. Right now, it's very uncoordinated. We need to have more of like a unified OS platform, a unified app development, a lot that we see with smartphones, but now, smart home. I think we're going to have to start to see more and more of that in order to have much higher volumes and you not having to lock customers into a particular, provider's systems. You want to be able to make it a bigger pie for everyone, so everyone takes a slice. So, thank you very much.